So how Mr. H said the other day that it takes the same amount of time to burn fuel no matter what. So we have to have a time spark. Well, what happens after idle once I start to go up in RPM? How the heck do we advance the timing on a distributor? Obviously on a PCM I can do whatever I want. How'd they do it back in the day? I'm glad you asked. Let's talk about vacuum advance on distributors from back in the day. So how did we actually get that spark to occur sooner when we were actually moving up in RPM and things of that sort? So, just like any engine, we can't just sit there at, 800 and 900 RPM and, like an idle and just be happy there. No, if we want to go somewhere, we've got a transmission, we got gear ratios, we have an RPM range that we have to meet, which means since fuel takes the same time to burn no matter what, I have to advance the spark in order to advance the engine to do anything in that aspect. So how did we do it back in the day with distributors? Well, we're going to start with the first form, which was, well, actually there's two forms. It just depends on which manufacturer wanted to really attempt the other ones. We have a vacuum advance system where we actually used, you guessed it, right in the term, engine vacuum. So let's talk about this distributor. It's the one we've kind of used for most of the videos so far. We have our points, we have our condenser, just in case we have voltage spike, and we also have, our little cam lobes on here for however many cylinders we have. And we talked about, the period where we're saturating the coil, our dwell, and then, going to open up that circuit to induce the spark. We've talked about all that, but how do I advance that? That sounds, Mr. H, that sounds pretty fixed and concrete to me. How do we actually change that? Well, the way we actually change that, I'm glad you asked, and now that I think about it, I really should have a vacuum gauge up here to see if this one still works. But oh well, for right now. We think about engine vacuum. We go back to, now we're going back from, let's see, 111, which was engines course. And we're thinking about, okay, as an engine idles, okay, we're expecting anywhere between 17 and 22 inches of vacuum. Some new engines, you can even have more than that because of just how the tolerances are and everything else. So we're looking at that at idle. We're actually looking for a lack of atmospheric pressure that's happening inside that intake manifold. Cool. If I were to open that throttle though, now I'm letting all that air push itself in to take up for that lack of atmosphere. And now it's going to even out. Now there's not such a big disconnect between atmospheric pressure and what's happening inside that manifold, because now I'm actually letting that air work itself in at a faster rate. So the way we use that is we use that to advance the timing, because if an engine's just sitting there happy as can be just at idle, it's going to be high vacuum. If you open up that throttle blade and you have your foot to the floor, you might go down to zero. So why not use that to our advantage? So you'll see on these distributors here, you'll have this huge diaphragm here with a vacuum hose that'll go to it. Keynote, if you're working on a distributor and you're trying to hook all this stuff up for the first time, make sure your vacuum hose goes below the actual carburetor throttle plates. I've seen some people that put it above, and that's not, you're not getting anything out of that. You need it to be below the throttle plates to actually get engine vacuum. It can't be above. You can't just put it in like the intake hose or something like that. It won't work. You need engine vacuum, real, true engine vacuum. So as low as you can go. But most carburetors and plates and stuff, you're going to see actual designated ports for that, depending on the application. But what we have is a diaphragm here that works off of engine vacuum. And what it actually does is, I don't know if you can see this, but it sort of has a swashbuckle lever plate on the bottom here. And the way this works is based off of engine vacuum. This whole entire assembly, so you can see this is not really just a fixed plate. It kind of hovers there. If I were to move that lever, the whole entire action moves with it. So I can actually advance or retard the timing by taking this whole entire assembly and actually rotating, a little farther forward or a little farther back, depending on if I need the timing advanced or if I need it retarded. So that's how we originally did it. We just used engine vacuum based on, idle, high vacuum. Open throttle, low vacuum. So we used that to our benefit. We actually could mechanically change where everything sat. So it wasn't just changing the points, it's changing everything around the camera centric to decide, hey, I need that spark sooner. So instead of, let's say before 8 degrees, before top dead center of the compression stroke, I need it at like 14 degrees or 18 degrees or something along those lines. That's how we actually advanced the timing on older style distributors with a vacuum advance. Other ones that were common were ones that can work off of centrifugal force. So let me see if I can find some other ones here, depending on what you had. A lot of these, now I think most of these are actually running off of engine vacuum to advance the timing as is. Here's another one where it is no longer the points, but it's actually using sort of like this Hall effect style sensor that is just watching for the closest point of contact there to decide when to send the spark. But you can see also it's using vacuum advance and letting this whole entire piece to actually turn to advance. But we have a couple other ones here, ones that can also work off centrifugal force. But overall, I think just about all of them that I have here are working off of vacuum advance. But there's one or two different styles of mechanical advance we can go over, but that's just a short video there, just talking about how do we advance spark timing in older style vehicles before we had the benefit of having computers. So that's just a little bit into that. Today's computers, they can do it so much faster. Just remember, guys, on that's mechanical parts. You cannot beat the speed of electronics. So that's another thing that let us change so many things. We could actually change or retard, not just, let's say, once we can actually, if we wanted to, we could change stuff per cylinder, adjust things per cylinder if the computer can read enough information. So it's not just, this is for everything, there's no mechanical gap as far as time goes with today's vehicles. So that's where we stepped up from there. That was great for its time. It still has places in the world. Some guys still swear by it as far as, racing and things like that. There's still a place for it. But in today's cars, it's much more beneficial to have no moving parts, no wear items at all, and just use the computer because it is so much more faster, like lightning speed above and beyond what these could ever do. So that was just a little bit about advancing the timing way back in the day with Mr. H. Move on to the next video.